Good evening, my dear JEE 26 and 2027 students. The class 11 syllabus on full swing. Lecture number 2 of center of mass. In the previous lecture, we have seen what is center of mass, how to find it, the formulas for multiple particles, including the integration part. And then we studied and by hearted the center of mass of standard geometries like spheres, cones, arcs, sectors, rods, everything. Right? And we did all kinds of questions. Today, in this particular lecture, we are going to see how the center of mass moves. All right, we are going to study the dynamics of it, motion of center of mass, and how Newton's laws get modified for a multiple particle system. It's a modified Newton's law. All right, and based on that, we'll see the boat problems, or one mass moves this much, how much should the other mass move so that the center of mass stays at rest, those kind of questions as well, right? So nice to see all of you. Rama, Aishu, welcome. Hi Vidya, welcome Adarsh, good evening. Yes, everybody is here, I hope. And mark your attendance by smashing that like button down there, and also subscribe to the Vedantu JEE English channel, and register for the MV Mega Vedantu Scholarship Admission Test. It's happening very soon. Dates are coming close, 4th, 5th, 11th and 12th of October, with 2.5 lakh participants, and they are going to battle it out in their respective grades. So if you are 11th standard student, you will be battling with 11th, 12th will be battling with 12th with the same syllabus of 12th standard. 11th will have different syllabus, okay, and you will be getting lots of prizes, scholarships, and also report card. You will understand where you stand, and this report card is going to be very much in detail, okay? So make sure you're registering for it. It's going to happen throughout the country in various centers. Just register and you will get to know where is the nearest center for you. All right. Oh, Dilip, I'm so glad you loved the podcast, and all my secrets are out. Hi, Darshini. Good evening. Nice to see all of you. I hope you all were there in the lecture number 1. I remember many of your names. You were there in lecture 1. So if you have missed lecture 1, please watch it. Okay. Cool. Like the video. Yes. Subscribe to the channel. Amazing. Let's begin with the class, and starting off with the dynamics of center of mass. See, I'll tell you one simple thing. If 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 the particles if the particles of a system if the particles of a system they move then the center of mass may also have motion. Kind of makes sense. Like, for example, I tell you, there is one particle here, it is moving like this, and then there is another particle here, which is, let's say, moving like this. This is particle labeled 1, this is particle labeled 2. Their center of mass is somewhere here. Because both of them are moving, it's quite possible that their center of mass will also start to move. But there is also a scenario where the center of mass may not move. Maybe, example, particle 1 moves here of same mass, and particle 2 of the same mass is moving this side. Then possibly that the center of mass could be at rest. The center of mass could be at rest, or it could be in motion. That is the reason why I have used the word may. May means it expresses a possibility that it could move, it could not move, depending on the scenario to scenario. Is that clear? And this is exactly what we are going to study, where we'll try to figure out what's the velocity, momentum, acceleration of center of mass, and also the scenario where the center of mass is at rest, and what's the condition for it. Okay. Now, simply speaking, it's straightforward. See, if I tell you that the position vector of the center of mass is given by, for multiple particle system, m1 r1 plus m2 r2, like that, mn rn, the whole thing divided by m1 plus m2, like that, till the nth mass. Now what I will do is I will take the derivative on both sides. Okay, I will differentiate this, so it will look something like this: d by dt of RCM. Now this term of M1, M2, M3 like that till Mn is a pure constant. I can take it outside the derivative and I will be left with d by dt of M1 R1 plus M2 R2 like that till Mn Rn. Okay, so that is what it is. Great. Now, what is the derivative of position vector? The derivative of position vector is nothing but velocity vector. So it is the velocity of the center of mass. Rate of change of position is velocity. So this will become velocity. This will become 1 by m1 plus m2 like that till mn, no doubt about it. Now here you just have to take m1 derivative of the first vector position plus m2 derivative of the second position vector like that mn derivative of the nth position vector with respect to time. These masses being constant, they will just come outside the derivative. So therefore, solving this, what do I really get? This is rate of change of the first particle's position. That means it is velocity of that first particle, then velocity of second, third, like that. This is the nth particle velocity. So therefore, I am left with m1 v1. v1 is dr1 by dt plus m2 v2 like that till mn vn. And you can divide this entire thing with this scalar number m1 plus m2 like that till mn. So this is the velocity of the center of mass. Very straight and forward. Yes, Dilip, lucky people out there. Awesome. Oh, issue. That first crush one is a small part of that bigger podcast. You should see the bigger, that I think around 40 minutes podcast. It has everything. All right. So we can probably block this off for our further use. Okay. Now, if I take that velocity and further derive it, imagine I take the velocity of the center of mass and I tell I'm going to differentiate this over here. I will also have to take the derivative on this side, which is m1 v1 like that till mn vn vector, the whole thing divided by m1 plus m2 like that till mn. What will happen? Derivative of velocity. What is it? Rate of change of velocity is acceleration, but this will be more specifically acceleration of the center of mass. Now over here, using the same logic, you will have m1 derivative of the first velocity, then you will have derivative of the second velocity, and like that you will have the derivative of the nth velocity, right? The whole thing divided by that scalar addition m1 plus m2 like that till mn. So what do I get the acceleration of the center of mass as? Obviously, rate of change of velocity of the first particle is the acceleration of the first particle. Same thing, m2 a2 like that till the nth particle, it will be mn an. An will be derivative of the nth velocity. Whole thing divided by that addition m1 plus m2 like that till mn. So I'm going to just block this off. This will give me the acceleration of the center of mass. Now please mind it that since this is a vector equation, that means it is very sign sensitive. So some velocities could be positive, negative if you are talking in one dimension. But if it is 2D or 3D problem, then you are allowed to just substitute it as I cap, j cap format. So maybe mass is 3 kg, velocity is something I, something j, something k. Same thing with mass 2, velocity 2 will have I, j, k. And when you solve this equation, you will finally get the velocity in I, j, k format. Same thing applies to this one. This is also vector equation. So if it is an ijk form, substitute the ijk form. And if it's one dimension, then you will have to just take care of the signs. One side will be positive, the other side will be negative. Automatically, the final answer will come out with the right sign. Is that absolutely clear, everyone? These are the two major formulas. Now let's put these things to use and see how does it come out. I've just put up the printed formula over here. Okay. And let's see some basic questions. Let's probably do this particular question and then we'll go to more questions. Okay. Here comes the first question on your screen. This was asked in JEE 2025. There are 4 particles ABCD mass m, 2m, 3m and 4m respectively at the corners of a square. They have accelerations of equal magnitude A and direction shown, the acceleration of the center of mass. Now, many students, what they thought is because the accelerations are A, spread out equally in all the directions, many kids wrote the answer as 0. But will the answer be 0? Think about it carefully. Read the question again, everyone. Okay. Sir, I have a doubt. If we watch the lectures, how to make our brain to solve any type of tricky questions? Well, whatever questions you solve from the teacher, try to solve the same questions using your own brain again. And then push yourself to similar questions in your textbook problem solving book. Identical problems, whatever we solved in the class. That builds more confidence. As you solve more and more questions with your own hand, you get that confidence. And when you get stuck, you have to go back to your mentor or your teacher. So if you're in my batch or whatever, in your teacher's batch, whether offline or online, go back to them, ask help, because remember, it is never a journey of a student alone. It is always a journey of a student and a teacher. Because if a student could learn just from YouTube or just from, I don't know, recorded classes, then we should not make new content. We should not create new batches. We can just give you a hard drive of all the lectures. So it is always a journey together. And also your friends, parents play an important role in that. So you have to constantly get that feedback, ask doubts, improve, correct your mistakes, see different tricks and interact. And that's how you improve, right? All right. So my dear students, over here, the masses are different. So that's the reason why the answer won't be 0, as you can see. Okay. The answer will not be 0 because the masses are not the same. If the masses are equal, obviously the answer will be 0. So let's start by writing our acceleration equation. There will be 4 terms, obviously. So you will have m1 a1 plus m2 a2 like that upon m1 plus m2 like that till fourth mass and the fourth acceleration, and here also you will have the fourth mass over here. Okay, let's write down the first mass. The first mass is m. The first acceleration is upwards, so I will put it as a j cap. Does that make sense? Why a j cap? Because it is upwards in the y-axis. The second mass is nothing but 2m, I believe, if I'm not wrong, or a mass is m, is it? Oh, so sorry guys, A's mass is m, so we'll have to start from here. So sorry. Okay, we'll start from here. A's mass is m. The acceleration is in the left direction, negative x, so it will be m into minus a I cap. Minus a I cap because it is left side. The second mass is 2m, and the acceleration is negative j cap, so minus a j cap. Okay, plus 3m multiplied by, this is 3m. Acceleration is in the positive direction of x-axis, so a I cap, plus the final acceleration is upwards, so 4m and a j cap. That's what it is. This whole thing, so sorry I overlapped with the diagram, but it's okay. M plus 2m plus 3m plus 4m. That's what it is. So as you can see over here, we have minus ma, minus 2ma, plus 3ma and plus 4ma. Minus ma and minus 2ma will make it minus, oh, but this is j cap, this is I cap. We cannot add that. We have to be careful. I cap will only add with I cap. So we have 3m a I cap and minus ma I cap. So 3 minus 1 is 2. So 2m a I cap will be there. Here we have minus 2 j cap and here we have 4 j cap. So 4 minus 2 is again 2. So 2ma we have j cap over here. This whole thing divided by 1 plus 2 3, 3 plus 3 6, 6 plus 4 10. So you will have 10m over here. M and m will cancel and you can see that we can take out 2 common outside and we are left with I cap plus j cap, the whole thing divided by 10. Now 2 divided by 10, that's 1 by 5. So it will be I cap plus j cap, the whole thing divided by 5. That is the acceleration of the center of mass. Okay, not minus, this will be plus. Yes, a by 5 I cap plus j cap. Is that absolutely clear? Yes, option number D. Perfecto. Dilip, Rama, excelente. Can I please put up video for Python? You mean the CBSE 12th standard computer science related, or in general, what is the use of Python in computer science, or what exactly is your requirement, Pritija? All right. Gaming of Shimon sir is only on Tamil channel, not on the Vedantu JEE English channel. Here you have, yeah, different teachers. Tamil channel has different teachers. All right, everybody has their own responsibilities and roles, right? Okay, cool. All right. So let's begin with the next question coming up on your screen. And here comes that particular question. Observe carefully. Observe carefully. In this particular example, you have a pulley which is suspended from that roof, and there is a thread which is hanging over the pulley, which is connected to one mass over here and another mass over here. This mass is m, this mass is, let's say, 3m, and the system is let go. Question is, find the acceleration of the center of mass. It's a brilliant question. Let's see how do we solve it. Find the acceleration of the center of mass of the system. We have solved this kind of question in Newton's laws, where you have a pulley and two masses, you leave it. One mass goes up, one mass comes down, the heavier is down, the lighter one is up. We know how to find the acceleration also, and direct formula is also there. How do we figure out the center of mass? Acceleration. Many students usually think the answer is 0, because if this goes down, the other goes up. Sir, same acceleration up and down, so they will cancel. Wrong. Think again. The masses are different again, so it can't be 0. Is that okay? Right? All right. Demonic, you will find my lectures in the near future. Don't worry. And you will find it in VBuddy. Go to VBuddy, you will find it. VBuddy, if you go right here, you have to go to VBuddy. Right now I'm not signed in, but go to the resources tab. You will find VBuddy. In that, you will find every single class of mine. Every single class, all chapters 11th and 12th. Okay? Cool. Hi, Unique. I hope Demonic, it's clear. So first thing, what I will do is, if I use the formula of acceleration of center of mass, well, I know one thing, that this one is going to come down, this one is going to go up by the same magnitude, So if I write it in vector equation, the upward is positive, the downward is negative. So it will be, first mass is m, the acceleration is a j cap, the second mass is 3m, but the acceleration will be minus a j cap, and the whole thing divided by the total mass, which is m plus 3m. Okay. So ma minus 3ma, everything is in j. So 1 minus 3 is minus 2. So minus 2ma j cap, whole thing divided by 4 times of m, which will give me 2 by 4 is 1 by 2, cancels. So minus a by 2 j cap. But the issue is, I do not know the value of a. I cannot leave the answer in terms of a. It will not be given in the question. Don't worry. We know by Newton's laws of motion, what is that acceleration? That acceleration is bigger mass, that big mass, minus that smaller mass, the whole thing upon the total mass, multiplied by acceleration due to gravity. The bigger mass is 3m, the smaller mass is obviously m, the total mass is 3m plus m, and g is as it is. So 3m minus m is 2m, 3m plus m is 4m, the whole thing into g. So therefore, you are just going to get g by 2. You're just going to get g by 2. So all I have to do is substitute g by 2 over here. So you'll have minus, and you'll have g by 2, the whole thing by 2, j cap. So therefore, 2 to 4. So minus g by 4 times of j cap. That is the answer. This tells me the acceleration is net down, as straightforward as that. Okay? Everybody with me on this? If you want, you can put the value of g. Yes, g you can put it as 10. So 10 by 4 is 5 by 2. Yes, you can put it as minus 5 by 2 also. Not an issue. Or minus 5 by 2, which is nothing but 2.5. Wow, my board hangs. Yo, what to do? Wait for it. Nothing else I can do. See, got Random issues. Ever since these Windows updates are coming. Come bro. Okay. 5 by 2 is also, what is it? 5 by 2 is also 2.5. So minus 2.5 J cap is also okay. Nothing wrong in it. Okay. Everybody with me? Awesome. Now, let's say I give you a question like this. Okay. Let's say I give you a question like this. Pandu will come very soon, Uni, in today's lecture. Hi, Ria. Good evening, everyone. Both sir, my friend wants to become aerostess and somewhat our CS ma'am is teaching, don't understand. Ayo, what tangent you went off? Our teacher, my friend wants to be for aerostess. Why do you need Python? I didn't understand the relationship between Python and aerostess. But you just want to study Python because it is there or something else? Question. The next question is as follows: If 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 two particles have same mass but moving in opposite directions opposite directions, then the center of mass will, option A, stay at rest, option B, will be in motion, option C, can't say, it can do anything. What do you think is the correct answer for this? Two particles of the same mass but they are moving in the opposite direction. What do you think will the center of mass do? Will it be at rest, will it be in motion, or it is indeterminate? It can be this or it can be that. What do you think is the right answer for this? Rama, come on. Maverick saying center of mass is at rest. Oh, is it? Fine. I remember last year many students requested for computer science lectures, although we couldn't get much time to deliver that. But okay, since you guys are saying, maybe we'll plan it in a near future then, now that we have time. Fine, cool. It's for Python. I'll tell you what, in this question, imagine this particular mass and this particular mass. Nothing has been said about the velocity. Let's say this is V2 and let's say this is V1. So if you ask me velocity of the center of mass, it will be m times of minus V1 because it is this side plus m times of plus V2, the whole thing divided by m plus m. Now this will just become m common, V2 minus V1, m plus m is 2m. So this will become V2 minus V1 by 2. That is the velocity of center of mass. Now, as you can see over here, there are two possibilities. One possibility is, imagine V1 is not equal to V2. If they are not equal, they will not cancel out. So velocity of the center of mass will not be zero. The other possibility is that imagine the speed V1 and V2 are equal, then they will cancel out and the velocity of the center of mass will be zero. Hence, the right answer will be can't say because it depends on their velocities. Is that absolutely clear? Answer C. It depends on their individual motions. Either they are equal or not equal. That will decide what the answer should be. So it's a very tricky question. A simple one though. But again, if you are in a hurry, because of that haste, you will make a mistake. Otherwise, it is very straightforward. So you have to spend that time. Let's go to the next question on your screen. Two blocks of masses 10 kg and 4 kg are connected by a spring of negligible mass and placed on a surface. And velocity is given of 14 to the bigger one, which is 10 kilos. In the direction of the lighter block, the velocity of the center of mass is how much? The velocity of the center of mass is how much? Interesting question. Let's think. There is this heavier mass here is the lighter mass, and here it's surface, maybe like this. Okay, and they are connected by a spring like this. This is 10 kg, this is 4 kg, okay, and you have given a velocity of 14 meters per second to this guy. Question is center of mass, what is the velocity? If you give 10 kg some velocity, will indirectly 4 kg also get some velocity? The answer is yes, but not immediately, after some time. Reason is the spring. This is an impulsive velocity, meaning you are taking a stick or a bat or some rod and you are hitting it like this. So the moment the rod or that bat hits that mass, it will start moving. But the spring has not yet compressed. It will take some time to compress, some milliseconds here and there. And once it starts compressing, then it applies the force. And because of that force, that next mass will start moving. So this word is very, very important. This impulse gives this velocity, means the 10 kg block, the 10 kg block gets 14 meters per second instantly, but the spring absorbs that shock. The spring absorbs that particular shock, because of which 4 kg block slowly starts moving after the impulse, not during the impulse. So therefore, at t is equal to 0 or very close to 0, you will see that velocity of that, 4 kg block, velocity of that 4 kg block is going to be negligible. It's hardly going to have anything. So you can ignore the velocity of 4 kg block. From this, we can find the velocity of the center of mass. VCM will be m1 v1 plus m2 v2, the whole thing divided by m1 plus m2. The first mass is 10 kilos, the velocity is 14. Second mass is 4, but the velocity is 0. Whole thing divided by 10 plus 4. So that will be 10 multiplied by 14 divided by 14. 14 cancels, and the answer will be 10 meters per second is the velocity of the center of mass. So 10 is option C over here. That is absolutely correct. Got it? So this particular concept is very important at the start of the problem, because many kids feel that something is missing in the problem, sir. Sir, we left the question thinking it is bonus because the velocity was not given. Nothing like that. The shock will be absorbed. So once that shock gets absorbed, the spring will start compressing and then it will start pushing that block, but it will take some few seconds for the block to gain some decent velocity. Okay, what is impulse? Yes, impulse means you would have heard it. His behavior or her behavior is very impulsive, means sudden, very moody types. Very quiet a person is, and suddenly he will become very angry, or suddenly becomes very noisy, or suddenly becomes very sad. So that is impulse, sudden. Okay, like a shock. There is a ball which is sitting quietly. One bat comes and hits it. Sudden change. So that is called as an impulse. Is that okay? All right. All right. Fine, Pritija. We will conduct those classes very, very soon. Don't worry about it. Okay. Right. Okay. Great. Great. Now that we have understood how to use these formulas, where is it? This one and this one. Let's go a little bit more and try to figure out what might be the formula for momentum, and then we'll go to force. That is the final aim. I have asked this question to many students. What will be the momentum of center of mass? And many times kids tell me, sir, it is m1 p1 plus m2 p2 plus mn pn, the whole thing divided by m1 plus m2 plus mn. A lot of times kids tell me this is the formula. If you also thought this is the answer, it is absolutely wrong. This is not the right formula. Please do not use this. Okay? Please do not use this. It is wrong. Okay? It is wrong. I'm highlighting that. Deliberately, I wrote it because this is a common mistake in a hurry during the examination. Now, can you guess why it is wrong? That is very important. Okay, fine, it is wrong, and I'm telling you it is wrong. Why is it? Why are we finding it at t is equal to 0? The previous question, because I think the question was exactly that. The velocity of the center of mass impulse is given to that block. At that moment only you have to find. So when the impulse is given, what will be the center of mass's velocity? That's what the question is. Okay, I don't think it was explicitly mentioned, but that is the understanding, because other than that, after some time, this guy's speed might reduce, will increase, things will change. So we are not asked what happens later on. We are just asked at that moment what has happened. Okay, during that impulse. The PDF Rishwant will be posted in the description box as well as in the comment section. Now I'll tell you why this is wrong. If you go with the velocity of the center of mass formula, remember it is m1 v1 plus m2 v2 like that till mn vn upon the total mass m1 like that till mn. Okay, take this guy over here. So this will become m1 plus m2 like that mn into vcm, and on the numerator side you will have m1 v1 plus m2 v2 like that till mn vn. Now what is m1 v1? It is first momentum. What is m2 v2? Second momentum. Like that, mn vn will be nothing but the nth momentum. Momentum is mass into velocity. What is this? This is nothing but the total mass. This is nothing but the total mass, and this is nothing but velocity of the center of mass. Now this tells me a very interesting thing. This is total mass into VCM. That means it is nothing but the momentum of the center of mass. So momentum of the center of mass is just P1 plus P2 like that till Pn. That is very interesting. There is no m1, p1, m2, p2. It's just the simple addition of the momentums. That's it. So this is the right formula. This is the right formula. And then I can just say the momentum of the center of mass is the total momentum of the system. Is the total momentum of the system. That's it. This is what this equation means. Everything will have its momentum. You just find the total momentum. That is the momentum of the center of mass. Plain and simple, nothing great. So that is what it is. So say for example, I've been told there is a mass over here of 2m, which is having velocity v, another mass m over here, which is having velocity 4v, and another mass of 3m over here, which has a velocity of 2v. If I ask you, find the momentum of the center of mass, find the momentum of the center of mass, all you have to do is find the total momentum of the system. The total momentum of the system is momentum of 1 plus momentum of 2 plus the momentum of 3. The first mass momentum is 2 times m into v, but it will be j cap. The next mass is m. The velocity is 4v, but in I cap. And the last mass will have negative momentum 3m into 2v, but this will be I cap. So as you can see, this is also I, this is also I. This is 4, 3 2s are 6. 4 minus 6 is 2. So this will become 4 minus 6 is minus 2, sorry, minus 2mv I cap, and this will be 2mv j cap. So this will therefore become 2mv. It is negative I cap plus j cap. That is the momentum of the system. But we know momentum of the system is also the momentum of center of mass. So the momentum of center of mass is 2mv negative I cap plus positive j cap. That is the answer. Is that clear how we find it out? Yeah, very good. Amazing. We have taken 2 also common outside. Great. Now, there is a very interesting thing when we try to find the kinetic energy. And I want you to pay attention to this. This is a very important theorem. Very few people will tell you this. It's not there in NCERT, but it is used in JEE in many places, especially in advanced Olympiads and some crazy mains questions. Let's say, for example, we try to find the kinetic energy of a system and also the kinetic energy of the center of mass. And let's see how does it turn out to be. Say, for example, there is a mass of maybe 2 kg and maybe there is a mass of, maybe 4 kg or let's say 6 kg over here. This mass is, let's say, moving like this with a speed of 1 meter per second. And this mass, let's say, is moving over here with a speed of 3 meters per second. Okay, I'm going to make you calculate few things and let's see how does it turn out to be. Okay, first thing we'll calculate is if I'm sitting on the ground frame, how much is kinetic energy of each mass? So kinetic energy of the first mass will be half the first mass, which is 2 kilos, into the first speed. Doesn't matter what the direction is, it's a scalar quantity. So that first kinetic energy will be nothing but 1 joule. That is the kinetic energy labeled 1. What is kinetic energy 2? It is half second mass, which is 6, into the velocity, which is basically 3 square. Now 3 square is 9, 6 by 2 is 3, 3 9s are 27, so this will be 27 joules. That is the second kinetic energy. Now let us also try to figure out what is the kinetic energy of the center of mass. Okay, where is the center of mass? The center of mass will be somewhere over here. The center of mass will be moving maybe like this. This is VCM. What is the mass of the center of mass? I'm not asking you the location. I'm asking you what is the mass of the center of mass. Mass of the center of mass. Center of mass is an idea where you completely condense the body into a singular point. So you're combining 2 kg and 6 kg together into a singular point. So 2 plus 6 will obviously become 8 kg. Oh, perfect. So if I ask what is the kinetic energy of the center of mass, you'll be like half mass of the center of mass. Oh, velocity of center of mass, we have not yet figured out. No issues. VCM will be M1 V1. So M1 is 2, V1 is -1, plus M2 is 6, V2 is 3. The whole thing divided by M1 plus M2. So this will be -2, 6 3s are 18 divided by 8. So 18 minus 2 is 16. 16 by 8 meaning 2 meters per second. It's positive, that means the assumed direction is correct. So this will be nothing but 2 square. Okay. So 2 cancels, 8 2s are 16. So this will be 16 joules. So kinetic energy of center of mass. Also, I have figured it out. Fair enough? Till this point, absolutely clear? Okay. Kinetic energy of center of mass also, I have figured it out. Now comes the interesting part. I will sit on the center of mass and try to reimagine the entire scenario. I will sit on the center of mass and try to reimagine the entire scenario and let me see what do I really get. Velocity of center of mass I already know. I'm not taking the ground frame anymore. And I know center of mass is now moving at 2 meters per second. So if I sit on the center of mass frame, what will I see these objects doing? For example, this 2 kg and this 6 kg. Come on, think carefully. If I am moving with 2, mass in front of me is moving with a little bit more speed of 3. So the relative speed between this 6 and center of mass will be 1 in the forward direction. Same direction, because I'm moving slow. This mass is moving slightly faster than me. So the relative speed between both the masses will be 1 meter per second. So this will have 1 meter per second. If you ask me this guy's speed, well, this is going this way, this is going this way, relative speed will be higher. It will be 3 meters per second. Is that right? Everybody with me? Okay, perfect. Hi, Mitra. Awesome. Now, carefully see what is going to happen. Let me now figure out the velocity from the center of mass frame. So, kinetic energy of 1 from the center of mass frame. Kinetic energy of 1 from center of mass frame will be half into mass into velocity square, which is 3 square. Okay, so 2 cancels. This will just become 9 joules. Kinetic energy of 2 from the center of mass frame, half into mass into velocity is 1. So 6 by 2 is nothing but 3. So kinetic energy of 2 from center of mass. This is kinetic energy of 1 from the center of mass. What do I do with this? You might ask. Okay, let me do one simple thing. What is the total kinetic energy from the center of mass frame? What is the total kinetic energy from the center of mass frame? It will be 9 plus 3, which is obviously 12 joules. 9 plus 3, which is nothing but 12 joules. If you had asked me over here, what is the kinetic energy from the ground frame? Just from the ground frame totally, it will be 1 plus 27, which is 28 joules. That is the total kinetic energy of the system from the ground frame. Now focus your attention only on these numbers. This one, and this one. This one. Notice if you are able to see something. Some kind of mix and matching. If you do, you will find something is adding up to something. You are getting some kind of a relationship. Are you able to see that? This is the total kinetic energy as you are seeing. This is the kinetic energy of the center of mass. This is the kinetic energy with respect to the center of mass. Can you see it? Okay. Yes, Anjali, that will be definitely good enough. If you watch my class 11th and 12th physics classes, that is good enough. Yes. Can you see that? Yes, Anjali, my lectures are in detailed only, like especially these classes, or even if I watched my older classes like Nurture and Pathfinder, they are also in detail. So I cover all the concepts. In fact, I go a little bit beyond NCRT only. Okay, right? And if you want, one shot also, that is there, but I don't recommend one shot at this point of time. You have good amount of time, Anjali. Please watch my detailed classes. The current ones are very good. And if there is some topic which I have not taught now, or maybe you don't find it, you can watch my Nurture or Pathfinder playlist. All topics are there. Okay. Yes, the difference is 12, 16 and 12 adds up to 28. Exactly. So we are able to see one clear cut thing, which is this 28 is 16 plus 12. So we just saw 16 plus 12 is 28. Is it just a coincidence? The answer is no. Is it that only 2 particles are there? That's why? No. Even if I take 4, 5 particles, still the answer will be like that. And is it 1D because of that? No. Even if it is 3 dimension, still I will get such a relationship. And what is this relationship? Let's understand. 16 over here stands for the kinetic energy of the center of mass. So kinetic energy of the center of mass plus the kinetic energy from the center of mass is the total energy. What a brilliant relationship. 28 is the total energy from outside. And that brings me to that final thing over here. Very, very important, guys. Very, 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 very important. It is not there in many lectures I have seen. Many people will skip this. the kinetic energy of the system with respect to center of mass plus kinetic energy of the center of mass for some frame, okay, with respect to, let's say, ground frame, example, with respect to the ground frame, will be the kinetic energy of that entire system with respect to the same ground frame. Very important relationship. Very important relationship. I'll repeat again over here. This 28 is this kinetic energy with respect to the ground, which we figured out over here. Individual masses, individual energies, if I take them up, it is coming out to be 28. This is the total energy of the system as I am seeing, is equal to kinetic energy of the system from center of mass. So when I shift it to the center of mass, I'm sitting on that and then I'm seeing the relative energies and adding them up. It came out to be some 12 joules. That is this one. Kinetic energy of the center of mass, meaning if I go to the ground frame, look at the center of mass and then calculates its energy, that is what that represents. That sum comes out to be this. This is a very important theorem and is valid for 1D, 2D, 2, 3 particles, 100 particles, etc. Now, what is the direct implication of this? Let me tell you. Imagine if somebody decides not to sit on the ground frame, but some other frame. So this is not necessarily ground frame. You can choose any frame. So with respect to some frame, then if I put a frame here, I can also put another frame over here. So think of it like this. Somebody decides this is our frame F, and maybe there is a system. This is my system. Particles, they all are moving here and there. Okay, so this is how it is. This is your system, and their center of mass is going to be over here. So kinetic energy of the system is kinetic energy of the center of mass, kinetic energy of the center of mass plus from the center of mass whatever kinetic energy you see. Okay, now the frame is our choice. I can choose whatever frame I want. If the frame changes, tell me what and all will change. Will this term change, first term, second term, or third term? Answer it in the chat box. I choose new frames. Which one will change? It's kind of obvious that this can't change because it's already mentioned kinetic energy of the system from the center of mass. So the only thing which can change is this and this. If the frame changes, the kinetic energy of the system with respect to center of mass will remain the same, but the kinetic energy of the system, all right, with respect to that frame, and kinetic energy of the center of mass with respect to the frame will be different. If this is whatever it is, let's say 16 joules, sorry, not 16 joules, what is it? It was 12 joules. So this 12 joules will not change, but other things will change. That 16 and 28 can change. What can be the least possible kinetic energy? Kinetic energy can't be negative. So the least value that you can get is 0. So if now my frame itself becomes the center of mass frame, if the frame itself becomes the center of mass frame, then this is not changing, this is changing, this can be lowered. It can't become negative. The least it can become is 0, and that will become 0 when my frame is itself the center of mass. It's like saying I'm sitting on the center of mass and asking what is the kinetic energy of the center of mass? 0. You are sitting on the center of mass and asking its own velocity. It is going to be 0. So that is the reason why both from center of mass is the least kinetic energy that can be observed. You can choose any other frame, no matter which frame you choose. Every time the total energy will be different and higher. But when you sit on the center of mass, the kinetic energy that you get will be the least. That is the conclusion of this, and it is a very, very important conclusion. The kinetic energy observed from the center of mass is the least energy observed. The logic, again I'll explain. The kinetic energy of the system with respect to COM can never change because it's with respect to center of mass. Whatever relative motion is happening, that can't change. Kinetic energy of the center of mass will be different because if I choose new frames, the speed will be different. So the total energy will also be different. So if I want to minimize my total energy, I will sit on this so that this term will become 0. It can't become negative. So if I want this to be the least, I can't change this. I'll make this the least, and this will be at max or at minimum 0. It can't be lower than 0. Is that cool? Everyone, did you understand this concept? Very interesting property of center of mass. Many people will skip this, but there could be interesting questions like find where the kinetic energy is minimum, which frame has least kinetic energy, the least observable kinetic energy. So this is that kind of question. Okay, goal. Now let us move on to the Newton's law for a system of particles. Newton's law for a system of particles. Say for example, we have one mass over here. It has some kind of acceleration over here, some other mass, some other acceleration, some another mass, some other acceleration, like that, nth mass and nth acceleration. This then becomes my system. This then becomes my system. Okay, this then becomes my system. And the center of mass will be somewhere here. The center of mass, it might have its own acceleration, let's say ACM. ACM is the total acceleration of the center of mass. There could be some external forces like F1, F2, F3, F4, Fn on that particular system. Okay, these are all external forces. And there could be also internal forces within the system. Okay, like this one with this one and this one. These are all internal forces. The Newton's law says that, see, till now we used to say, okay, we have a block, you apply a force, it will accelerate. You always used to apply Newton's law for one body, for one particle, for one mass. But never did you ever apply till now where you have one particle here, pulley is there, and one block is here. Did you ever apply Newton's law for this entire system as together? No, we used to always draw separate bodies. Now this law enables me to allow to apply Newton's law for multiple bodies, even if they have different acceleration. Yes, even if they have different acceleration, even whether they are connected, not connected, doesn't matter. Till now, we used to take this body separate, pulley separate, nothing like that. Now, this is for any system with multiple bodies connected internally, externally, doesn't really matter. So, this says that you forget the internal forces. So, the internal forces, forget it. Just worry about the external forces like F1, F2, F3, like that till Fn. And that will give me the total mass, which is M1 plus M2, like that till Mn, into the acceleration of center of mass. So this tells me that my net external force is the total mass of the system into acceleration of the center of mass, and internal forces can't change the acceleration of center of mass. Whatever internal forces are there, it can never affect the total system's acceleration. It can affect individual acceleration like A1, A2, but can't change the acceleration of the total system. It can't change ACM, but only individual accelerations like A1, A2, etc. can be changed. That's it. So this is your Newton's law for a system of particles. This is your Newton's law for a system of particles. Both the statements are important, that internal forces do not matter, external forces only will be important for changing the acceleration of the center of mass. Very important. Good evening, Akshay. Good evening, Balaji. Hi, Twinning. Hi, Maheshwari. Yes, Muthu. Yes, Rama. This problem opened your eyes. Very good. Excellent. Now, what is the way in which you apply it, sir? Okay, fine. Very fancy looking equation. Sir, can you show me one crazy application of this? Why not? I'll show you. Just some time back, we did a question. No? Where is it? Yes, this one. We'll redo the same question again. We'll redo the same question again, but using Newton's law for a system of particles. Oh, is it, sir? We can do it differently also. In the previous method, what we did is we figured out individual accelerations through Newton's laws separately, right? FBD drawing and all that. And then we applied using M1A1 plus M2A2 formula by M1 plus M2. So that is what the method we used. Now I will try to find the center of mass's acceleration through this particular formula. How exactly? We need a system. So for me, this is my system. This is my system. Okay. Let's figure out what are the external forces only. Don't worry about internal forces, because that's what it says. Internal forces can't affect center of mass. It is only the external forces. As you can see over here, one gravity is there, external, which is mg. On this 3m also, you will notice a 3 mg force is there, which is external. Not just that, the tension is coming from outside. So there is a tension over here and here also. And we know the value of tension. It is 2 m1 m2 divided by m1 plus m2 multiplied by g. We have seen this in Newton's laws. So 2 3s are 6. So 6 m square g square, sorry, m square g by 4m. Mm cancel, 6 by 4 is 3 by 2. So 3 by 2 times of mg is the tension. These are the only forces acting on the system. So now, if you look at the center of mass, it will have some acceleration, which is ACOM or ACM. Think of it like this. Now you have a singular mass. Whose mass is basically 4m, and the forces on it are mg is there. You also have 3 mg over here, and you have t over here and t over here. And as a result of this mass is going to accelerate, ACM. Now it looks simple. Now it looks as if the entire body or the system has been condensed into one dense mass, which is M system. and you're trying to find the acceleration of that point mass, and you're only now worried of the external forces. You're not worried about what is internal. Internal will anyways get cancelled out. Well, now it kind of makes sense. So using our Newton's laws of motion for a system, net force, which is external, will be total mass of the system multiplied by acceleration of center of mass. So net external force, should I take T plus T positive or mg plus 3mg positive? Center of mass is going down, so downwards will be positive. So that's why it will be mg plus 3mg minus T is equal to total mass, which is 4m, into I do not know what the acceleration is. So this will therefore become 4 times of mg minus 2 times of T is equal to 4m ACM. What the hell is T? T, we just figured it out. It is 3 by 2 mg. So I'll just put 3 by 2 mg over here. 2 will cancel. It will become 3. 4 mg minus 3 mg. 4 mg minus 3 mg is equal to 4 MACM. 4 minus 3 is 1. So it will just become mg is equal to 4 MACM. mm will cancel. So g will become 4 times of ACM. Therefore, ACM will become g by 4. Wait a minute. This is exactly the same answer which we got. ACM is g by 4. Go back. We got it as g by 4. Wow, so cool. Here we got minus. Don't get scared. It's just saying that it is down, and there is nothing wrong in that. Here also we are saying it is down only. How, sir? You assumed it is down. We assumed it is down and we got it as positive, means our assumption is correct. So whether you go via Newton's law or whether you go via m1a1 plus m2a2 by m1 plus m2, answer will be the same. Yes, I accept that this method will be longer here by Newton's laws. Maybe in some other problem it could be shorter, some other way. So that is why this method is important. Okay, how do you find the center of mass's acceleration? Interesting. Everybody with me? Say for example, I give you another question over here. Spring constant is 100 Newton per meter. The compression let's say this is 4 kgs. Let's say this is 2 kgs. There is a force of, let's say, 200 Newton. There is another force of 50 Newton over here. There is another force of 50 Newton over here. And right now, it is also mentioned that this guy has some 4 kg has some acceleration of 2 meters per second square. Okay, all this is given. Compression will come to it. Hold on for that. Can we figure out what is the acceleration of 2 kg block somehow? Just using this particular data, or maybe, yeah, I think that much is enough. Yes. Just using this particular data, can we figure out what is the acceleration of 2 kg block? Okay, let's think about it. Now, this much situation is given to me. Okay, this much situation is given to me. If I consider this entire thing as one singular system, then that one singular system will have a total mass of how much? 4 plus 2, which is basically 6 kilos. Spring force will become internal. Spring will become internal force. So don't even worry about it. Externally, all the surfaces are smooth. So only these forces are there. So we will have a 200 Newton force from here, and we will have a 50 Newton force from here. And as a result, bigger force is towards the right side. The center of mass which is there, it will have some kind of acceleration like this maybe. So if I apply Newton's modified law, which says the net external force will be the total mass of the system multiplied by acceleration of center of mass. External forces are just 250, that's it. Mass of the system is 6. Acceleration, I do not know. So 200 minus 50 is nothing but 150, which is 6 times of ACM. So therefore, ACM will be 150 by 60. How much is that? 15 by 3, that's 50. So 25, just check this out. Yes. So this will be 25 meters per second square. That is the acceleration of center of mass. Is this absolutely clear? Everybody with me? Understood till this point? How we find acceleration of center of mass? Okay, nothing else was given, just the forces were given, not even the 2 kg masses acceleration was given to me. In fact, I can use this now. To figure out how much might be the acceleration of 2 kg block. How? Observe. I understood now that center of mass has 25 meters per second square acceleration. So now I will assume this guy's 2 kg acceleration to be A2. And now I know for a fact that ACOM, or acceleration of center of mass, will be M1A1 plus M2A2 by M1 plus M2. Use this. ACOM is 25. Okay. Mass 1 is basically 2. Sorry, not 2. My bad. 4. Acceleration 1 is 2. Mass number 2 is 2. Acceleration, well, I do not know. Whole thing divided by M1 plus M2, which means 4 plus 2. Okay. 4 plus 2, 6. 25 into 6 we will have over here is equal to 4 2s are 8 plus 2 times of A2. 25 6 are 150 is equal to 8 plus 2 times of A2. Therefore, 2 times of A2, 150 minus 8, which is 142. Therefore, A2 will be nothing but 71 meters per second square. Crazy. We got second mass's acceleration just with such minimal information, guys. Not just center of mass, but also acceleration of the center of mass. Isn't it fabulous? Isn't it fabulous? What happened for the spring mass in the system? Spring's mass is there, but we always choose ideal springs, Rama. What is the mass of an ideal spring? Always 0. So we ignored that. Okay. Even in the previous question, the mass of the pulley, ideal pulley, massless. So 0. Otherwise, we had to consider that. Wow, sir. But I'll tell you, the wowness will not end over here. The wowness will continue now. I'll tell you why. We have figured out a couple of things till this point. All we have done is used Newton's law for a system of particles. Center of mass 25 meters per second square. And what is this? A2 is 71. This we got it as 71 meters per second square. Can we figure out how much is compression or extension? Okay, basically, I do not know that compression or elongation. Whatever is that compression or elongation, can we find that out? Yes, absolutely. So how, sir? How are you going to find that out? I'll tell you what. Either look at this mass or this mass and try to draw the free body diagram. And let's see what exactly happens. Let's say I consider maybe the 4 kg mass. Nothing wrong in it. I'm just considering the 4 kg mass and show the forces acting on it horizontally. Vertical, I don't care. So one force is obviously 200. There is some acceleration which is there of 2 meters per second square. All right. And maybe there is one spring force over here. I do not know whether the spring is elongated or compressed in the first place. Getting my point? I do not know that. You are thinking it is compressed. I don't know. How do you know? So I am just going to assume that the spring is applying some kind of force, maybe like this. Chuma, I'll assume it. Nothing wrong in that, right? So this is the force by the spring. If I'm wrong, I'll get a negative answer and I will recalibrate again. Don't worry about it. That's it, nothing else. Now, if you apply normal Newton's law, you will say 200 minus the spring force is mass into acceleration. Okay, Fs is there. So 200 minus 8 is equal to Fs. Okay, Fs is 200 minus 8, which is 192 newtons. Oh, luckily it is positive. That means the direction of the spring force, is as it is. The direction of the spring force is as assumed as it is. Okay. Now what? If the spring is applying a force like this, think when can it apply a force like that? If the system is compressed, imagine the spring is compressed versus that same spring is elongated. How will the forces on the blocks be? When it is compressed, it will push the blocks like this. When it is elongated, it will pull the blocks inwards. So this is the case of compression, and this is the case of elongation. Which of the two scenarios do you think is valid? This 4 kilo block is being pulled here. That means, sorry, not pulled, pushed here. 4 kilo block is being pushed here. That means this is the right scenario, and this is not the scenario right now as per this question. Say for example, I got the force as negative 192 Newton. Then what will I think? I will think the assumption is wrong. So the spring force is opposite. Spring force is this way. So this block is being pulled. That means the spring will be elongated. So because of this value and the direction, I am able to conclude the spring is now, compressed and not elongated. And from this, we can find how much is the, elongation or compression. In this case, compression. So let's use that. So using this particular scenario, Fs will be spring constant multiplied by x. Fs is 192, K is 100 multiplied by x. Therefore, x will be 1.92 meters, and this will be obviously compression. So this could be a proper JEE advanced question with a passage. Yes. F is not minus kx. Rama, be careful. I have never said F is minus kx. I have warned you in advance. Never use that minus sign. That minus just denotes direction. I'm interested in the magnitude. So a lot of people make that mistake and use minus kx and they get confused. Don't do that. Okay. It depends on which body you are considering and all of that. So we have concluded so many things with such a minimal information in this question, and that's why center of mass is also called as a silent killer chapter. Suddenly, you will not even know that this is a question of center of mass. You will think it is a question of work per energy or collisions or just Newton's laws. But then you will realize, oh, wait a minute, I can find the acceleration of center of mass. From that, I can find the acceleration of the second mass. We can also figure out how much is the compression or elongation also. So all these things we were able to do because of center of mass, isn't it? Thank you, Kailash. I'm so glad you loved this question also. And if you have not yet liked the video, please like the video because I've put in a lot of effort. And by the way, I just made this question on the spot. Like you saw, this was just on the spot. I just remembered I had solved this kind of question maybe 2-3 years back. Okay. And that is how my teaching is. I go with the flow, even in my lectures. I usually start with a blank page, but I use the slides because it saves a little bit of time. So that is your Newton's law for a system of particles. And suddenly you will need it. And I'm telling you, these problems are not enough. Whatever I've just done for giving you the complete idea, you need to solve more. And that's why we'll need more practice. This is just telling you how we have used it in these couple of scenarios. Now, the further application of Newton's law of motion for a system of particles is when the center of mass comes to rest. Imagine we have a system and somehow we are able to conclude that the center of mass is going to be at rest. You'll be like, sir, how are you so sure the center of mass is at rest? Maybe it is given or it is understood for some reason. There will be many particles over here, like this, like this, like this. Center of mass is at rest. Now, when can you say center of mass is at rest? If the net external force is zero, if the net external force is zero, what can I say? Acceleration of center of mass is zero. Therefore, what can we say about the velocity of center of mass? Lot of you will say, sir, zero. Wrong. Center of mass's velocity is constant. I'm just saying it is constant. If net force is zero, does not mean center of mass is at rest. Maybe it is moving uniformly. Constant speed. Okay. So now if I want that also to be zero, it's very simple. If I initially find the center of mass to be at rest, and this is also true, then center of mass will always be at rest. Now, if initial velocity of center of mass is zero, then center of mass is always at rest. Always going to be at rest. So what is the essential condition for the center of mass to be always at rest? There are two conditions. The first condition is this: the center of mass net external force should be zero and the initial velocity of the center of mass should be zero. So this is the first condition. This is the second condition. Only then the center of mass will always be at rest. Is this absolutely clear? Both of them. Just because initially it was at rest does not mean finally also it will be at rest. If always the forces balance and cancel out, only then it will be at rest. Then what can we conclude? See, I'll tell you what. Because the center of mass is at rest, I can very easily say that VCM is going to be 0. VCM is going to be 0. If VCM is 0, then M1 V1 plus M2 V2 plus Mn Vn, the whole thing divided by M1 plus this Mn is going to be 0. Therefore, numerator will be 0. So M1 V1 plus M2 V2 plus Mn Vn is going to be 0. Therefore, what I will do? Velocity is displacement by time. So M1 into displacement 1 by time plus m2 into displacement by time, like that. Mn into nth displacement by time will be 0. T will cancel and I will get m1 s1 plus m2 s2 plus mn sn is going to be a big fat 0. Now this is the formula which you need to know. You can avoid all this calculation in the examination. Any question where you know that center of mass will be at rest because of these two conditions alone, you can immediately write down first mass into first displacement plus second mass into second displacement plus nth mass into nth displacement. Their sum, vector sum, will be 0. Sign sensitive. That's it. Directly, you can start your problem with this. Don't waste your time in all of this. Like, sir, what are those examples? So many examples are there where center of mass will be at 0. Example: imagine there is one roller skate like this, and there is one pandu standing on it, and that roller skate, right? Oops, what happened to Pandu's smile? Okay, and that roller skate, okay, it is on a smooth surface. It is on a smooth surface. Another example: there is a block here, there's another block here. They are all connected by a spring over here, and let's say a spring is right now compressed and then you leave it. So I can show it in the compressed form or maybe elongated, anything. It is right now compressed heavily and then you release it. Or let's say another example where there is a boat like this, there is a pandu here, and there is a beautiful champa over here, and they are floating on a lake. That boat is floating on a lake or a pond, something like that. All these surfaces are smooth. There is no resistance offered by the lake. Negligible, water resistance. Water resistance, viscosity is negligible. Okay. Now, in all these scenarios, you will notice one thing. Pandu on this plank, when he walks, or the spring block system when compressed, or Pandu moving towards Champa, Champa moving towards Pandu, they will apply the forces internally on each other. Like when this Pandu walks, he will push the plank, that pushing, pulling action, that is internal between the plank Pandu. The blocks are compressed, blocks are compressing the spring and released. The spring force is an internal force for the system. Champa walking on the boat, Champa applies force on the boat, which is a part of the system. Pandu pushes the boat, maybe internally, like this is walking. That is again all internal forces. Externally, water is not applying any force. Smoothly the boat can go here and there. Very easily it can slide, slippery it is. So in all the examples over here, one thing is that the external force in the horizontal direction is zero. Not just that, initially the spring block system was compressed and then left. The Pandu Champa boat, they were at rest, then they start walking. The Pandu was on the plank and then he starts moving. So initial velocity was zero. This quickly tells me that center of mass is going to be at rest. And if center of mass is going to be at rest, I am allowed to use this equation. I'm allowed to use this equation. Pandu's mass into Pandu's displacement will be Planck's mass into Planck's displacement. This mass into this displacement into this mass into that displacement will be zero. Pandu's mass into displacement plus Champa's mass into displacement plus boat's mass into displacement, their sum will be zero. Understood, guys? In every scenario, we are allowed to use that equation. So therefore, I can say that sigma mi si will be zero in all the cases. In all the scenarios, I'm allowed to use this. And these are some of the examples where you are allowed to use them. Is this absolutely clear? I'm user, why are you crying, man? Abhinav, yes, we are coming to more questions. Hi, I can't understand Tamil literature, man. You can better put it up in English. Okay. Hi, Amit. Let's do a question on this. Here we have a question. Two particles which are initially at rest. This is the previous year of JEE, if I'm not wrong. Under the influence of gravity or attraction, their speeds are v and 2v. At some instant, the speed of the center of mass of the system will be. So there is one mass here, its speed is v. Another mass over here, the speed is 2v. And why are they moving towards each other? Because of some internal force. Some internal force is there. So what is the velocity of the center of mass is what they have asked. So center of mass, what is the velocity? Okay, think carefully. They are moving towards each other. They are accelerating towards each other because of their forces. Masses are not given. So if you ask me, for this particular system, this force is internal. External force is zero. So center of mass shouldn't move. So therefore, the center of mass should be at rest. As simple as that. Done and dusted. Internal force cannot change the acceleration. So the answer is a big fat zero. Okay. So they were initially at rest. That is also given. That is also given. Initially at rest. So finally also they will be at rest. Is that clear? This is direct application of this condition. External force and initial velocity are zero. Then we can say the center of mass is always going to be at rest. Direct application. It is a previous year JEE question. Moving on to the next one coming up on your screen. Here it is. This is JEE 2022. Let's see. A two block of masses 10 kg and 30 kg are placed on the same straight line, 0, 0 and x0 coordinates. Okay. The block of 10 is moved in the same line through a distance of 6 centimeters towards the other block. The distance through which the 30 should be moved to keep the center of mass at the same place. Interesting. Let's draw the coordinate axis first. This is our coordinate axis. This is y. Okay, this is x. my first mass of 10 kg is at 0, 0. So this is my 10 kg mass, which is at 0, 0. The second mass is 30 at x, 0 is 30 kg, which is at x, 0. Okay. I do not know what that x is. Doesn't matter, maybe. The 10 kg block is moved in the same line 6 centimeters towards the other block. So I'm moving this block like this by 6 centimeters. Question is, how much should the 30 kg be moved so that center of mass will stay there? So that is very, very crucial. Center of mass is given to be at rest. It's kind of obvious 30 kg shouldn't move towards the right side. It will definitely move towards the left side. I will assume the displacement to be S2. Is X given? Not given. Do I need it? I don't think so. Without that also we'll get the answer. The moment center of mass is at rest, I've just told you one famous formula. The moment center of mass is at rest, this equation holds true. Individual mass into individual displacement addition will be 0. Let's use that. So I can say M1 S1 plus second mass, second displacement is 0. First mass is 10 kilos, displacement is positive 6 because it's towards the right side. Second mass is 30 kilos, displacement is negative S2 is equal to 0. Therefore, 60 is on that other side will be 30 times of S2. So therefore, S2 will be 2 centimeters. But S2 was already assumed to be towards the left. So therefore, 2 centimeters towards the left, or basically the other mass or the first mass. That's what the answer will be. So the answer is 2 centimeters towards the 10 kg block, which is option C. Is this clear? How do we use that particular equation? Amazing, right? Good evening, Sangam. Everybody got it? Give me a thumbs up, guys. This is very important preliminary question. First we did, lot of questions on this Newton's law of a system of particles, this one, and all of that. The special case is this, center of mass is at rest. I gave you this question where center of mass was always at rest. So nothing great. And this one, to keep it at rest, how much should the other mass move? This is common type of question. I move this mass this much, how much will you move the other mass so that it will be at rest? This is a common type of question. Now, the next one over here. Two people, 55 kg, 65 kg, opposite ends of a boat. The length of the boat is this much, mass is given, 55 kg man will walk and sit with him. If the boat is in still water, the center of mass of the system will shift by. Come on, everybody spam the answer in the chat box. No need of calculation, only directly. Yes, initially it looks scary, but it is not. Yeah. We are now going to do a scary problem after this. That will be the last question for today. Two people are there. One person moves, other person moves, boat will move, whatever happens. Guys, the water will not apply any force. This is just like this one. I gave you the example, right? This Pandu Champa, Pandu moves, Champa moves, boat will move here and there. Okay, center of mass will not move. External force is 0. That's it. So, as simple as that, center of mass is going to be at rest. Hence, the answer is just going to be 0. The center of mass is just simply going to be at rest. Option C for Captain Shreyas. Everyone with me? Cool? Okay, sir. Perfect. But sir, give me an example where I know the center of mass is at rest and I have to figure out how much will the boat will move. That's why I've got this beautiful example in front of you. Read the question. Read the question. Hi Sangam. Good evening, my dear. In a boat of mass 4m and the length is L, two people are there. One person's mass is m, the other person's is 2m. Boat mass 4m, this guy is m, the other is 4m. A is m, I believe, B is 2m. They are on the opposite ends. Separation is L. A travels L by 4 relative to the boat. So this guy is going L by 4 this way, not this way, obviously, or else will be in water. And B goes 3L by 4 relative to the boat. Kinds of like means that they are meeting each other. This guy moves L by 4, This guy will move 3L by 4. They both will come towards each other. They will be at the same place. Maybe they will chit chat. And meet say, find the distance traveled by the boat on the water when they meet. Interesting. Okay. Let's draw simplified version of them and let's think what exactly might be happening. This is our boat of mass 4m and length L. Here we have one Pandu. Here we have one Pandu whose mass is m, another Pandu whose mass is 2m, and finally they will meet over here. Okay, it is given that they meet over here. I'll tell you one big blunder which will happen is with the displacement. A lot of people are going to make a mess up with the displacement only. So this is L by 4, this is 3L by 4, and this is where they end up meeting. This is where they end up meeting. Okay. Now, again, I know that the center of mass is not going to move. Okay. So I'll start off with that only. Center of mass of A plus B plus the boat is going to be at rest. So I'm allowed to use M1 S1. In this case, it will be MA, mass of A into S of A, plus mass of person B into displacement of B, plus mass of the boat, okay, mass of the boat multiplied by displacement of that particular boat. This entire thing should be 0. Okay, perfect. Now, what is the mass of A? It is nothing but M. Displacement of A, lot of people will put L by 4. I've seen this. Lot of people. Sir, what is wrong? It is given, no? The displacement is L by 4. Okay, fine. Tell me one thing. When I write this equation, these displacements S1, S2, S3, what are they? With respect to what are they, rather? They are always with respect to the outside ground frame, not with respect to the boat. So, when you read the question, you will realize L by 4 is actually given relative to the boat. Kind of makes sense. And this person will move 3L by 4 relative to the boat. So, if the boat itself moves, when this person moves, this person might come here maybe. So, the actual displacement might be different. When the boat might move here, the person is meeting here, but the boat has moved. So, the person might move more than L by 4. Getting my point? So those displacement S1, S2, S3, S4, they're always relative to the ground frame, not with relative to some other object. So sir, we did not worry about it in this problem, sir. Why are you worrying about this problem then? Like this question. In this particular question, here also this person has moved 6 centimeters. How do you know it is with respect to the ground? When it is not given, what is it with respect to? Obviously, it is with respect to the ground frame only. So here, luckily for us, S1 and S2 were both from the ground frame and not relative to each other. If the question was what is the relative motion, if the question was what is the relative displacement, then you can easily see this guy moved 6, this guy moved 2 towards each other. So relative displacement will be 6 plus 2, which is basically 8 centimeters towards each other. This would be the relative displacement towards each other. Is that okay, everyone? Now, in this question, the catch is only that we know the relative displacement. Oh my God. So what do we do, sir? Use the concept of relative motion. What is that concept? Displacement of A with respect to boat is displacement of A minus displacement of boat. Okay. This is given to me. This is L by 4 is nothing but SA minus S boat. Okay. So therefore, SA will be, check this out, SA will be L by 4 plus displacement of boat. This is one equation. So SA, I can just put it as L by 4 plus displacement of the boat. Okay. Next thing. Person B's mass is 2m. I'll put 2m. But displacement B, same logic again. So displacement of B with respect to the boat is displacement of B minus displacement of the boat. This is given to be 3L by 4. I have seen many students putting 3L by 4 here and then writing SB minus S boat. That is also wrong. Catch is this displacement is in the negative direction. So if you miss the minus sign, you are going to get a wrong answer. So this minus is because left side. This was positive plus L by 4 because it was towards the right side. So if you notice clearly, the displacement of the boat will be SB will be, my bad, S boat minus displacement of the boat minus 3L by 4. So I'm just going to use that over here. It will be displacement of the boat minus 3L by 4. Last term over here is mass of the boat, which is 4m. Displacement of the boat, I do not know. This is equal to 0. So as you can see, I have reduced it to one single variable, which is S boat, which I do not know. The rest, everything will cancel off, like mass and mass will cancel over here from all the three sides. Let's see what happens now. Therefore, L by 4 plus displacement of the boat plus 2 times the displacement of the boat minus this 2 will cancel. It will become 3L by 2 plus 4 times displacement of the boat is 0. Okay. S boat, 2S boat, 4S boat. 4 plus 2, 6, 6 plus 1, 7. So 7 times the displacement of the boat. 3L by 2, L by 4, nothing else. Yes. So L by 4 minus, this is 0.25 minus 1.5, guys, or you can just say L by 4 minus 3L by 2. That will become 6L by 4. So 1 minus 6, 5L by 4. So this will become minus 5L by 4 is equal to 0. Therefore, the displacement of the boat is 5L. 7 4s are 28. 7 4s are 28. This is the answer. Aswa, I'm very good. Thank you so much. How many of you loved the question and understood now? So we are not going to be happy with only one equation here. The problem is these displacements were never the actual displacements. So we were compelled to figure out the relative displacement and actual displacement relationship. So what we did, we used the relative motion concept and then substituted in the question. Love this problem. Okay, so whether it is 2 people, 3 people, there is also a question where monkey is there, balloon is there. It's the same thing. The monkey climbs the balloon, the rope is hanging from the balloon. The monkey moves this much, how much will the balloon move? Here the motion is in the vertical direction. It's just like this problem. Instead, it will be simpler because there will be only 2 terms, not even 3 terms. Okay, so that's how you solve it. Okay, 5L by 28. Yes, that is the answer. So it looks something like this, guys. The boat will move by some amount. You can see the boat will move by some amount. And because it is positive, it means the boat has moved left or right? The boat has moved right side. So this positive value means towards the right side. Because we were sign sensitive, remember that? Negative means negative left side, positive means the right side. So positive answer tells me that it is moving towards the right side. So we get the direction also. Is that okay? Now I have kept a homework question for all of you. Consider a system of 2 particles M1, M2. M1 moves with respect to by distance d, by what distance the other mass should move to keep the center of mass as rest. Okay, very straightforward. I'm pretty sure you will be able to solve it. Answer is there on the next slide along with the solution. So that was today's class. I hope you enjoyed it, loved it. Make sure you like the video and subscribe to the Vedantu JEE English channel. This was your Captain Shreyas. The PDF will be there in the description as well as in the comment section very soon. Okay, bye-bye. Take care.